This session includes a definition of big data and a description of big data characteristics and considerations. Additionally, you'll learn how unstructured data is fueling big data analytics and how this has influenced the analyst's perspective on data repositories. Think about what big data is for a moment. Is there a size threshold over which data becomes big data? Is it the number of rows or records? Is it the number of columns or variables? How much does the complexity of its structure influence the designation as big data? How new are the analytical techniques? There are multiple characteristics of big data, but 4 stand out as defining characteristics. You can think of these characteristics as 3V plus C. The huge volume of data, for instance, tools that manage billions of rows and millions of columns. The complexity of data types and structures, with an increasing variety of unstructured data. 80 to 90% of the data in existence is unstructured, part of the digital shadow or data exhaust, and the speed or velocity of new data creation. Additionally, the data, due to its size or level of structure, cannot be efficiently analyzed using only traditional databases or methods. There are many examples of emerging big data opportunities and solutions. They include such things as Netflix suggesting your next movie rental, the dynamic monitoring of embedded sensors in bridges to detect real-time stresses and longer-term erosion, and retailers analyzing digital video streams to optimize product and display layouts and promotional spaces on a store-by-store basis. These kinds of big data problems require new tools and technologies to store, manage, and realize the business benefit. Big data necessitates new architectures that are supported by new tools, processes, and procedures that enable organizations to create, manipulate, and manage these very large datasets and the storage environments that house them. Big data can come in multiple forms, everything from highly structured financial data to text files to multimedia files and genetic mappings. The high volume of the data is a consistent characteristic of big data. As we'll see next, most of the big data is unstructured or semi-structured in nature, which requires different techniques and tools to process and analyze. Big data is a relative term. For some organizations, terabytes of data may be unmanageable. Other organizations may find that petabytes of data are overwhelming. If you can't process your data with your existing capabilities, then you have a big data problem. The most prominent feature of big data is its structure. 80 to 90% of future data growth will come from non-structured data types. The 4 different separate types of data can be mixed together at times. For instance, you may have a classic Relational Database Management System, or RDBMS, storing call logs for a software support call center. In this case, you may have typical structured data. Additionally, you will likely have unstructured or semi-structured data, such as free-form call log information taken from an email ticket, or an actual phone call description of a technical problem and the solution. Another possibility would be voice logs or audio transcripts of the actual call that might be associated with the structured data. Until recently, most analysts would be able to analyze the most common and highly structured data in this call log history RDBMS, since the mining of the textual information is very labor-intensive and could not be easily automated. People tend to both love and hate spreadsheets. With their introduction, business users were able to create simple logic on data structured in rows and columns, and create their own analyses to business problems. Spreadsheets are easy to share, and end users have control over the logic involved. However, proliferation of spreadsheets caused organizations to struggle with many versions of the truth, meaning it was impossible to determine if you have the right version of a spreadsheet with the most current data and logic in it. As data needs grew, companies began offering more scalable data warehousing solutions. These technologies enabled companies to manage the data centrally, including the benefits of security, failover, and a single repository where users could rely on getting an official source of data for financial reporting or other mission-critical tasks. Another implication of this phase is that enterprise data warehouse rules, restrict analysts from building datasets, which can cause shadow systems to emerge within organizations, containing critical data for constructing analytic datasets, managed locally by power users. Analytic sandboxes enable high-performance computing using in-database processing. This approach creates relationships to multiple data sources within an organization and saves the analyst time of creating these data feeds on an individual basis, and faster turnaround time for developing and executing new analytic models.